Washington thought the 1980s trade war was just paper, tariffs, and politicians in suits. But deep inside Komatsu, a secret team wasn't interested in taxes. They were signing a hit order known as Maru-C. They ordered a machine so massive it physically broke the factory's robotics. Standard automation couldn't handle the heat, so they forced master craftsmen to hand-weld the hull like a battleship. From that obsession rose the D575A, a 152-ton monster that defeated every rival in the dirt, only to be killed by a silent enemy no one saw coming. In the 1980s, the trade war wasn't just suits arguing over tariffs in Washington, it was a street fight. While politicians talked, a much quieter, uglier conflict was being mapped out in the boardrooms. Komatsu, tired of being the underdog to the American giant Caterpillar, decided simple competition didn't cut it anymore. Under Ryoichi Kawai, they adopted a radical internal doctrine, Maru-C. Short for Encircle Caterpillar, this wasn't a slogan, it was a hit order. Based on the Japanese game Go, the strategy wasn't to attack head-on, but to choke off the enemy's territory until they couldn't move. Kawai wanted to break Caterpillar's stranglehold on the market. This philosophy filtered down from the top brass to the shop floor, driving engineers to design iron that didn't just outperform the Americans, it had to embarrass them. The first volley landed at ConExpo in 1981 in Houston. The industry showed up to see the usual yellow iron, but Komatsu sucked the air out of the room with the D555A prototype. This thing was a monster. It put out 1,000 horsepower. Back then, hitting 4 digits in a dozer was like breaking the sound barrier. Most engineers thought metallurgical and transmission tech couldn't handle that kind of torque. Komatsu stared the American engineers right in the eye and dared them to blink. The D555A was a calculated humiliation. It physically towered over Caterpillar's flagship D10. In mining, where tonnage rules, that visual dominance did the talking. It signaled that the American standard was already obsolete, but the D555A was just a warning shot. Then reality hit. The bottom fell out of the global economy in the early 80s. Mining got decimated and demand for ultra-large earth movers evaporated. The prototype D555A was parked in a warehouse to collect dust. To an outsider, it looked like a failed experiment, but inside Komatsu, Maru-C was still running hot. They called this the lost decade, but the engineers didn't waste a day. A core team retreated to the R&D labs. They used the downtime to treat the machine less like a tractor and more like a bespoke dragster. Management gave them a blank check. Forget the efficiency metrics that rule the assembly line, focus purely on raw performance. By the time the markets recovered, the landscape had shifted. Caterpillar had rolled out the D11N to secure their top spot. Komatsu knew the old prototype wouldn't cut it anymore. They needed a machine that rendered the competition irrelevant. The engineers made a hard call. They scrapped the original propulsion plan. They ripped out the SA-12V140 engine and dropped in the massive SA-12V170. That's not just a part number update, that's a different weight class. The displacement jump provided the torque needed to ensure that when this machine finally broke cover, it wouldn't just beat the D11, it would eat it. The result of that obsession debuted in 1991. It returned not as the D555, but as the D575A. The production model, the D575A2SR, pushed past the prototype's limits, eventually climbing to 1,150 horsepower. It was a weapon of industrial warfare, but in chasing the ultimate specs, Komatsu created a new problem. The frame weighed over 100 tons. It was physically too big for the factory that birthed it. Standard assembly lines were out. You can't roll a machine that size down a conveyor belt. Komatsu had to revert to a stationary bay method. Instead of the dozer moving through the plant, it sat like a battleship in dry dock while specialized teams rotated around it. It killed efficiency, but it allowed for obsession-level craftsmanship. They had built the ultimate weapon to encircle their enemy, but in doing so, they created a logistical nightmare. To understand the scale of this paradox, we have to pop the hood and look at the engineering that separated the mere earth movers from the monster. The D575A didn't start life as a dozer. When the chassis first launched in '91, it carried the designation SR, Super Ripper. At that stage, Komatsu had built a 100-ton pickaxe designed to crack hard rock in zones where blasting was illegal. It was a concentrated tool, meant to break ground, not move it. But field reports from the early adopters told a different story. The operators realized this thing didn't just break rock, it wanted to push it. So, in 1995, Komatsu pivoted. They launched the D575A2SD Super Dozer. This is the icon. They reinforced the frame and hung a blade on the front that defies physics. It holds 69 cubic meters, about 90 cubic yards. That's not a shovel, that's a swimming pool of dirt. To manage that kind of load, engineers installed a dual tilt system. This allowed operators to control 2 hydraulic tilt cylinders independently. You could pitch the cutting edge forward to bite into the hardpan or tilt it back to cradle the load. Crucially, it let operators steer with the blade tilting a corner down to drag the machine without cutting power to the tracks. It added a level of finesse to the brute force, bumping production by 15% in level dosing. Under the hood sat the SA12V170E. This was a 12-cylinder diesel, displacing 46 liters, churning out 1,150 horsepower. To get that power, they used massive water-cooled aftercoolers to cram dense air into the cylinders. But an engine that big generates heat like a blast furnace. To keep it from melting down, engineers ditched standard belt-driven fans for hydraulics. This meant the cooling fan speed was independent of engine RPM. You could idle the engine after a heavy push, and those fans would still scream at max capacity to prevent heat soak. That's a critical feature for the stop-start rhythm of a mine. But designing the monster was easier than building it. The D575A was simply too big for the robot lines at the Osaka mother plant. While smaller dozers rolled down the conveyor, the D575A sat in a stationary bay like a ship hull in dry dock. This process required the Takumi, master craftsman. The design called for welding cast steel nodes to rolled steel plates over 50 millimeters thick. That is a metallurgical nightmare. Welding cast steel to rolled plate requires perfect heat management. You can't just run a bead on steel that thick. You have to preheat the massive plates with torches to prevent thermal shock. If you get it wrong, the metal cracks as it cools. Robots couldn't feel the temperature of the steel. The Takumi could. They executed multi-pass welds by hand, turning a mass production factory into an artisanal workshop. The result was that each D575A was a bespoke project that bled resources. It forced Komatsu to pull their best welders off high-profit lines to toil over one machine for weeks. And when that was finally done, the headache continued. Weighing in at 152 tons, you can't just drive it out the door. It smashed every road weight limit in existence. It had to be stripped to the bone. Blade, ripper, tracks, cab, and chassis just to leave the factory. Osaka had built a king, but they needed a kingdom vast enough to house it. There was only one place on Earth with mountains big enough to move and a hunger deep enough to justify the cost. Komatsu had built a king, but Japan didn't have a throne big enough. That throne was found in the Appalachian Mountains, specifically the coal fields of West Virginia. The job was mountaintop removal. This wasn't standard digging, this was terraforming. Operators were pushing entire peaks into valleys to expose the coal seams beneath. It was the only job on the planet with the scale to justify the D575A's existence. The D575A2SD became the primary weapon for this war on geography. It carried a blade that measured 24 feet wide and 10 feet tall. The steel face alone weighed 22,000 pounds. That blade weighs as much as a fully loaded school bus. That massive surface area allowed operators to use a technique called riding the wave. By using the dual tilt system to pitch the blade back, they could cradle a rolling load of overburden. They weren't just pushing dirt, they were surfing it. But it took nerves of steel. With a blade that tall, you have a massive blind spot. You can't actually see the load you're pushing. You have to feel it through the seat of your pants. This technique kept the momentum high and the tracks gripping, reshaping the landscape with every pass. But getting the machine to the fight was a logistical nightmare. You can't drive a 152-ton bulldozer down I-77. This is where the local dealer, Risch Equipment, earned their paycheck. They had to treat the delivery like a military operation. The machine was stripped down to the frame, blade, ripper, tracks, cab and engine, and trucked up winding mountain switchbacks on a fleet of lowboys. Once they hit the mine site, teams used heavy cranes for a multi-day reassembly in the mud. This wasn't a quick job. Moving a D575A means weeks of downtime. Risch even had to invent new maintenance protocols because standard service trucks couldn't lift the parts. If a cylinder blew on a D575A, you didn't just swap it out, you called in a crane. And don't forget the undercarriage. With 150 tons of downforce, the D575A didn't just drive over the rock, it ground its own tracks into dust, making undercarriage replacements a multi-million-dollar headache. The effort paid off. The first superdozer hit the dirt at the Princess Beverly Coal Company in Cabin Creek in 1995. The numbers were terrifying. The previous fleet was averaging about 375 cubic yards an hour. The D575A pushed that to 750. It literally doubled the output. At the massive Hobart 21 mine, these machines became the backbone of slot dozing, shoving blasted rock into waiting buckets of 400-ton haul trucks. It drove the cost per yard down to levels the competition couldn't touch. At the peak of operations, 17 of these giants were running simultaneously across West Virginia. They earned the title King of Appalachia. American operators, usually die-hard loyalists to domestic iron, had to tip their hard hats. You can argue with a brand, but you can't argue with 1,150 horsepower. But that power cast a heavy shadow. The D575A became the face of the environmental controversy surrounding mountaintop removal. It was so good at moving mountains that it fueled the black wave of legal and environmental backlash that eventually strangled the industry. Despite the politics, Komatsu had made their point. They held the belt. They had the biggest, meanest machine in the dirt. But in the heavy equipment game, a monopoly never lasts long. As the D575A reigned supreme on the peaks, the industry grew quiet. All eyes turned toward Peoria, Illinois, waiting for the American giant to strike back. The industry waited for a challenger. Rumors swirled about an Italian ghost, the Akko Super Bulldozer. On paper, it was the king, 183 tons, bigger than the Komatsu. But thanks to trade embargoes, it never moved a yard of dirt in anger. It was a museum piece, not a tool. That left the D575A alone on the mountain. Naturally, the mining world turned their eyes to Peoria, waiting for Caterpillar to drop a D12 and take their title back. But the counterpunch never came. CAT engineers looked at the problem and realized they didn't need a bigger hammer, they needed a smarter swing. Instead of matching the D575A's sheer mass, CAT doubled down on the D11T carry dozer. They didn't add weight, they fixed the geometry. They redesigned the blade with a specific curvature that forced the dirt to roll rather than just pile up. In the dirt world, a rolling load has way less friction than a dead load. This allowed the D11, which is 40 tons lighter than the Komatsu, to punch above its weight class. It was a triumph of geometry over gravity. Then, they added brains to the brawn. CAT introduced auto carry. This system automatically feathered the blade height to keep the track slip at 0. It maximized momentum and saved the operator's back. CAT closed the production gap using silicon, not just steel. The decision was also purely logistical. The Komatsu D575A was a prisoner of the mine. At 152 tons, it takes 6 to 8 trucks to move it. Once you build it, it stays there. The D11T, at roughly 112 tons, is heavy, but it's mobile. You can float it to a new site without turning it into a construction project. Caterpillar ran the numbers and realized the market for a superdozer was microscopic. Market data showed that for every single D575A sold, roughly 20 smaller D475s or D11s moved off the lot. Komatsu had built a monument to engineering that almost no one could afford to buy. By refusing to build the D12, CAT let Komatsu hold the prestige of the world's largest title, while they quietly secured the profits of the actual market. Komatsu had built a legend, but legends are expensive to feed. As the calendar turned, the economic reality of the new millennium began to close in on the superdozer. By the turn of the millennium, the ground started shifting under the superdozer. While the D575A was king of the hill in Appalachia, a quiet crisis was brewing back in Osaka. The machine was becoming a victim of its own size, starting on the factory floor. You have to look at the manufacturing economics to see the first nail in the coffin. The D575A was a resource hog. It ate up the factory's capacity, demanding the best engineers and massive square footage for a machine that sold in single digits. In the time it took to hand-build one D575A, Komatsu could crank out dozens of D475s. Those smaller machines paid the light bills. The superdozer was a prestige project, and prestige doesn't show up on the balance sheet. Then the 2008 global financial crisis hit. Commodity prices crashed, and mining budgets evaporated. The D575A wasn't a standard purchase. It was a massive capex commitment with a long lead time. In a volatile market, nobody wants to tie up millions in a specialized giant. Operators switched to common, high-volume machines they could easily liquidate if things went south. Orders were canceled, and the production line ground to a halt. But the story isn't just about money. The job changed. The D575A was the undisputed king of push mining, shoving entire mountaintops into adjacent valleys. But the EPA started tightening the noose on the Clean Water Act. In 2011, the Spruce No. 1 mine veto changed the game. It effectively banned large-scale valley fills to protect streams. If you can't push the spoil over the edge, the D575A loses its purpose. Mines had to switch to load and haul. You had to pick the dirt up and truck it to a designated dump site. The D575A was a pusher, not a loader. Suddenly, the king was a fish out of water. Simultaneously, the hydraulic excavator took over. Machines like Komatsu's own PC8000 became the new standard. As ore grades declined, operators needed precision. They needed to pick the coal out of the waste rock. The D575A was a sledgehammer. The excavator was a scalpel. The PC8000 could load trucks fast and offer the selectivity the dozer lacked. The bigger is better philosophy was dead. The final bullet to the head came from the EPA. In 2012, Tier 4 interim emission standards kicked in. They mandated a 90% drop in particulate matter. For the D575A's massive V12, this was a death sentence. To meet those rules, engineers would have to bolt on complex after-treatment hardware, SCR, selective catalytic reduction, DPF, diesel particulate filters, and the machine's worst nightmare, cooled EGR, exhaust gas recirculation. Here's the mechanical problem. That hardware takes up space, and it generates immense heat. The SA12V170E engine already filled the superdozer's bay to the bursting point. And keep in mind, under full load, this engine was already burning diesel at a rate that could drain its massive 550-gallon tank in a single hard shift. There was zero room for the plumbing. Worse, the heat rejection load would have skyrocketed. They would have needed massive new radiators and cooling fans that simply wouldn't fit in the existing chassis. Komatsu faced a stark choice: spend millions redesigning the entire frame and cooling package for a machine that sold 1 unit a year, or let the giant die. The math was simple. Redesigning it was financial suicide. So in 2012, Komatsu pulled the plug. They focused on the D475A and let the superdozer fade into history. The specialized bays in Osaka were cleared for profitable machines. The era was over. But while the factory moved on, a few machines left in the wild didn't just disappear, they became legends. To find the last resting place of these giants and see them rust in peace, you have to travel to the very edge of the map. So, where do monsters go to die? Usually the cutting torch. When the contracts dried up, most of these 150-ton yellow beasts were cut into scrap metal. But a few survived, thanks to the sheer will of a few die-hard enthusiasts. These weren't corporate preservationists. They were veterans of the trade who didn't see these machines as depreciation on a balance sheet. They saw them as heavy metal history. They rescued the last surviving hulls from the scrap heap and gave them a permanent home in a private collection, saving them from the smelter. But these survivors aren't standard catalog models. These are Stockton Specials. Originally imported from Australia, they were modified to carry heavy-duty single-shank rippers. Standard D575As were pushers. These were rippers. They had to claw through hard caprock and geology so nasty it chewed up smaller machines. Standard D575As were just pushers, useless once the push mining stopped. But these had rippers, making them utility tools that could claw through hard caprock. That versatility is the only reason they didn't get melted down years ago. If you go to Cambridge today, you can climb into the cab. It's a time capsule of analog gauges and early joystick controls. But nothing communicates the scale of this thing like the photo. You've seen it on the forums. A standard pickup truck parked comfortably inside the blade of a D575A. That blade is 24 feet wide. The truck looks like a toy. The image does more than explain the Marussi doctrine than any spec sheet ever could. The ghost of the D575A haunts the industry in other ways too. It lives on in the persistent rumor of the Caterpillar D12. Go to any heavy equipment forum and you'll find guys swearing that CAT is about to drop a response. It's a phantom. Enthusiasts just can't accept that the Japanese champion went unanswered. The irony is, while Peoria never built a D12, the market decided to build its own. Enter Mearns Hire in Australia. They built the Aussie D12. These aren't factory prototypes, they are Frankendozers. Mechanics took a standard D11 chassis, stretched the frame, and dropped in a CAT 3512 V12, the engine usually found in a CAT 785 mining truck. That pushes the output to 1,250 horsepower, finally matching the Komatsu. It proves that the demand for ultra-heavy horsepower didn't die, it just became too niche for the factory assembly line. The Komatsu D575A stands as a tragedy of engineering hubris. It was a machine built to win a trade war that ended before the dozer ever hit the dirt. It serves as the ultimate proof that engineering brilliance means nothing without economic reality. It was too big, too heavy, and too thirsty for the modern world. But you have to admire the audacity of the attempt. In an era now dominated by sensors, automation, and efficiency, the Super Dozer remains the solitary yardstick by which all heavy iron is measured. It was the absolute limit of what we could do with steel and diesel. We want to hear from the veterans. Did you ever sit in the cab of a D575A, or have you worked around those modified D11s in the Outback? Let us know your stories in the comments. And here's the real question. With modern emissions choking engines, will we ever see a production dozer break the 150-ton barrier again? Drop your prediction below. If you enjoyed this deep dive into the heavy metal history of the trade, make sure to subscribe. We'll see you on the next one.